Alright folks, looking at this 2010 exam question 4, but it's focused on the topic of wastewater from a domestic dwelling. Part A of the question is asking to discuss using notes and freehand sketches 3 functional requirements of a below ground drainage system to ensure the safe removal of sewage from a domestic dwelling. So 3 functions that your system has when removing sewage from a dwelling. The first one and the most obvious one that I would put down is that the system itself has to be self-cleaning. So we're going to put down self-cleansing. That way it doesn't require constant maintenance. The way that's going to be done, remember I have to use sketches and notes here as well, combine the two in your answer. So the way that's going to be done is basically dictated by the slope of the pipework going from the house to wherever the main sewer is, or the septic tank if it's an individual house. And the typical slope that you would get when you're talking about any sort of drainage or pipework that concerns water would be 1:40. So what I'm going to do is just draw a really quick cross section of your site. You have your domestic dwelling on one side of it, and you're going to have your waste pipe. This is underground, remember, and that's going to be going off to the mains sewer. So that pipe that I'm drawing now, the cross section of it, the slope of that would be 1:40. And you'd label up everything else. So you have your main sewer, and your main sewer, if you're connected to the mains for disposal of waste, would normally be underneath a road or whatever else is around. So what you would want to be backing up that answer with is that the gradient of the pipework will ensure that the wastewater flows at the right pace. If it's too steep, that's going to cause solid waste to build up at the end, and if it's not enough of a gradient, it won't ensure a constant flow of waste. So you put those notes to go along with the sketch. The second main point of a function of this system would be to prevent the build-up of pressure. So because you're dealing with, methane gases and other kind of stuff, there will be a build-up of pressure from that. So to prevent the build-up of pressure, what you would put in place would be vents along that system. So again, we'll draw a cross section of our house on the site, and all we're going to sketch in is that, and you'll see these on your pipe, they're upright pipes going up the full length of the wall. They appear to go underground, and what they're doing is they're just vents for the actual wastewater pipe that, let's say, coming out in this direction. So if that's your wastewater pipe that I'm just drawing now, you would have your vent attached onto that, and it's just allowing those harmful gases to escape and not build up at the other end of the system. So that'll be your second function. Now the third function of a system like this, we have self-cleansing, we have to prevent the build-up of pressure. The third one that I would include in an answer would be that such a system has to allow access for maintenance. If there's any reason you need to get into pipework, if there's a blockage, if there's a leakage, whatever, you need to be able to access that. So we're going to say allow access for maintenance. Now there are 2 basic types of access that you can have. The first one, which you might recognize the most, would be your manhole. That would be for heavy maintenance that might have to take place, such as the replacements of pipes, or if there was a huge blockage in the system, you need access to a manhole. A smaller type of access, which you'll often see along these systems that are around the dwelling house before it actually gets to the main sewerage, will be what's called rodding points. And what that involves is, I'm just drawing, that'll be your ground level. So obviously your sewage pipe is flowing underground, and then at intervals you're going to have these rodding points, and what they are is just access points from the ground down to the drainage pipe. So let's say, for argument's sake, you had your direction of flow going the way I've just drawn the arrow. You can label all this up in your proper answer. Your rodding point would be that if there was a blockage from, let's say, this point onwards towards the next rodding point, you could put a yardstick down or a flexible pipe or something to clear it up. So that would be what's called a rodding point, and that would allow access for maintenance. So again, you back these up with your written answers as well, just what I'm saying here. Okay, so that'll conclude your 3 functions for part A. Now, part B of that question 4, 2010. The accompanying sketch shows the location of a manhole, so you can see it here on the sketch, at the intersection of a branch drain and the main drain in a below ground drainage system for a domestic dwelling. Using notes and freehand sketches show the typical construction details through the manhole from the foundation to the manhole cover. So that's what's actually focusing here on, that, and it's a section of what a manhole looks like. Indicate on the sketch the typical dimensions. Okay. So what we're talking about here is when you're going to see a manhole, it's basically focused on the main sewerage system. So the drain is going to be coming from the domestic house into the main system. If something goes wrong, you need to be able to access that point. So we're going to draw first of all our ground level, and what we put in place about halfway over is we put the cast iron cover that you would have for your manhole. So I just hatch that in so it's obvious that that's what it is, and label it up. So that's a cast iron cover. Now the cast iron cover obviously has to be held in place by some sort of a concrete sill, so we'll just put that in place either side of it. So that's actually just holding up the cast iron cover. Remember, this is a cross section. And then underneath here we're actually going to have our manhole, so if you needed to step into it, this is where you would be going. So what's happening underground is the wastewater pipe that we drew earlier on in part A is coming from the house, and it's going down the slope of 1:40, and it's flowing into the main system. Now the main system is obviously running perpendicular to this drain that came down, so a cross section of that, it might look something like so. Then we're going to encase that within our manhole. And then obviously the manhole itself has to have some sort of a cement structure or a concrete structure around it. And then the rest on the outside is going to be your hardcore or underneath the road, or clay or whatever else. Okay, so that's what the intersection of a manhole looks like with your drainage pipe coming from your domestic. I put in the direction of flow as well, so that's coming from the house into the main system, and then it's going obviously perpendicular on the main system. They did ask for measurements. The typical measurements you want to put in for a manhole would be the height and the width of the actual internal measurements, so when you're actually inside it. And typical measurements for that would be 1200 by 750. Another measurement that you might need to put in would be the actual cast iron cover. Now think about it, a person has to fit underneath this, so typically when you're talking about a cover it's going to be circular, you're talking about diameters in this case, so we put in 600 for that. That would be the minimum. It could be anything above that, but 600 would be the minimum, and that's your diameter of your cover. That would be a typical cross section of a manhole. Now the bottom section here, just make sure that it's obvious that that will be slightly sloped to actually run into the mains pipe, because when you have wastewater coming down here, you don't want it to build up in these kind of sections here. It makes it impossible to work in that manhole. So they will be sloped, so if any wastewater came down or other type of waste, it's gonna drip down or flow down into the main sewer pipe and then flow on from there. Okay, we'll take a look at part C then, the last part of the question. What they're asking in this part was, using notes and sketches again, describe in detail one test that may be carried out to ensure that the below ground drainage system is watertight. Okay. Two possible answers come to mind. The first one would be the smoke test, where you seal off all the pipework in the area that you want to test, and you have a smoke machine, and what that's going to do is it's obviously going to show any leaks, or where there's cracks you'll see smoke exiting the pipework. It can be a little bit difficult to do that with an underground system when it's covered over by clay and dirt, because if there is cracks anywhere, you're not going to be able to see it. You're only going to really see it at the open areas. So a more valid kind of an idea for underground pipework once it's covered would be to fill it up with water and then leave it for a period of time and go back and measure has any of the water escaped. Then you would know if there's a leak somewhere that it's leaking water, so obviously there's a problem there. So in order to actually sketch that out, so this is for part C, what I do is just do a cross section of the start of our pipe work. So let's say we have a drain running underneath. Again, slope 1 is to 40. And what we're going to do is you would have junctions spread across every now and again on your pipe work. So from one junction to the next, we're going to test if there's any leaks. So let's say for argument's sake we just break it there. We'll have a junction on the right and we'll have a junction on the left. What we're going to do is we're going to put down a down pipe which would fit into a connection here. We're going to do the same on this end, and you can actually block off those pipes left and right. So now you're just testing this area. Remember, this is your ground level here. This is all underground. Now what we will do is we will pour water in from one end. Obviously the whole pipe work will fill up, so I'll just shade that in blue. So we're going to fill that up. We're going to leave it for 2 hours, and then we return and we measure how much water has escaped. So if you were talking about water escaping, an acceptable amount would be, and this is going by kind of standard building regulations, so an acceptable amount would be 0.05 litres, so 5 millilitres basically, per metre of pipe work. Okay, and the typical pipe work you're talking about would be your 100mm diameter pipe for wastewater. So let's say for argument's sake you sampled a section of pipe work that was 10 metres in length, and you filled it up with water. You had it closed off on the left and the right hand side. The intervals are 10 metres apart. You put in, let's say, 20 litres of water. I'm just making these figures up to just give you a sample, and you came back later on that day, 2 hours later, and there was 19.5 litres left, so it had fallen by half a litre. That means half a litre has escaped within those 10 metres of pipe work. So you would take your half a litre, which is 0.5, you have it in 10 metres, that will work out on average as 5 millilitres per metre. Therefore that's an acceptable amount to leak. Anything above that, and you'd have to look at replacing the pipework because it's an unacceptable amount of leakage. It's getting in, it's damaging the soil around. Okay, so leave it at that. I'll do another video on septic tanks for individual houses.